Hello class. Today I'll be adding a vertical shift to the trigonometric graph functions for this week. Relatively, it's going to be simple. You're going to have to do a couple of questions regarding those, and then that should be it. Since we've been talking about the unit circles, as well as we've been doing also the trigonometric graphing, a vertical shift would be just a slight bit of addition to that. And eventually, when we get to two more components where we call phase shift and then, well, let's add here, phase shift and then frequency, or we commonly know this also as a period. All of these two, when we're incorporating these two things together into the context of trigonometric graphing, that's when it gets to be a little bit tricky and complicated. But for now, we need to make sure that we are able to take care of these two. I consider these to be the easier ones and these to be the harder ones, which we'll be starting on later this week. Okay, so first let's go over the amplitude. You've seen this picture before where the amplitude is just simply the distance from the midline to the top or the distance from the bottom to the midline. All of these are called amplitude and we notate by the letter A. And in terms of graph transformation for the trigonometric function, now we both have always been dealing with sine and cosine, just regular ones, they're both waves. Okay. However, when we're adding these components, the first one that says amplitude, the second thing that we're going to be learning is this plus d, and d we call it the vertical shift. Of course, there's b and c, or we commonly known this as the theta. But those two things are going to be skipped, and we're going to move right into the easier ones so that we can knock those out of the way and then try talking about the harder ones this week, like I said. So now, vertical shift. So let's go over some basics here. Now, if I were to give you an f of x squared, let's go back to late algebra 1 and quadratic functions. What is the equation of f of x plus 2? Well, it's simply x squared plus 2, right? And if you were to graph both of these into Desmos, we get something that's actually quite interesting. Because if we're actually going to plug in, let's say, x squared, we get a quadratic shape, as you can see. But once we do x squared plus 2, notice what happens in terms of graph. So this is the graph that we got. I know that you guys probably know where I'm going to go with this, but what happened? You take this graph, and if you say that it got thinner by, kind of like contracting, that's not the way. You're literally taking this and you're moving it up 2. So you go up 2. That's the question. That is the what's happening to this graph, because if you take a look, the graph shape is exactly the same. If I were to take this graph shape, let's say I draw this over, this green line over here, okay? And then if I were to take my pen and then simply just move it up, you can see how this graph, literally if I move it up to, it just matches exactly. Can you guys all see that? So because of this, we know that this is a graph transformation in terms of moving it up or down. So going back to the slides here, what is a graph transformation? It moved up 2. If it was f of x minus 2, you would say it moved down 2. And that's simply it. That's what vertical shift is in terms of the polynomial functions like x squared. Now we can use that same rule and apply it here. If it's sine of x, and if we plug it in here, we get sine of x plus 2, as you all know. What is a graph transformation? Well, what was your answer for your second question here? It moves up 2. So you're going to copy, Control C, and Control V. It just moves up 2. So now let's take a look at the values here. For sine, please remember it's 0, 1, 0, negative 1, 0. Now what's going to happen to all of these y values as you add 2 right next to it is that all of these y values would be moving up 2. I'm sorry, what am I doing? 1 and then 2. So these are the values that you're going to get when you're adding 2 to the y values, and that is what you're going to graph. In terms of technical part of the graphing here, so that's going to be my graph transformation. I know that I didn't talk about phase shift yet, so just please forget about that. I used K instead of D, but it really doesn't matter. So vertical shift, and we call it the midline. So these two are what we're going to be dealing with. So now the first question, it says graph cosine of x and cosine of x minus 1 onto the same graph. Now I know that some of you guys don't like to do the table, but that's okay. For as long as you understand that the cosine goes from 1, 0, negative 1, 0, 1. Those are your 5 essential points from 0 to 2 pi, 0 to negative 2 pi. That's your cosine of x. Now, because I want to draw the same thing onto the same graph, now it says to draw cosine of x minus 1 onto the same graph, right? So now, how would I be able to do that on the technical side of it is that I would just simply take this and move it down 1, right? So I'm going to move it down 1, and then it's going to look like that. But unfortunately, if you're going to be doing this on a piece of paper, how would I be able to get this without ever, having this shape, being able to freely move this around by having the grabbing tool and then just moving it around? So, okay. So I'm going to start from scratch. Let's say I'm trying to draw cosine of x minus 1 totally on my own. What I'm going to simply take a look at is the amplitude and the vertical shift, which we also call the midline, right? So then I'm going to take cosine of x minus 1, and then the vertical shift is negative 1, which means my midline is at negative 1. I'm going to establish my midline onto the graph by, I like to draw like these little dashed lines. I like to call this setting my foundation up, because once I have all of those foundations set up, it's really, really simple. Now, I'm going to move up 1, because my amplitude in this case, you can see how amplitude is 1, because it's just cosine of x. There's no number in the front, so that means it's implied that there's a 1 in there. So I go up 1, and then I draw my dashed line up at the top, go down 1, draw my dashed line at the bottom. Now that sort of gives you your frame. That's an F. That gives you your frame as to where the wave is going to happen. And then you apply the same rule. You first, at 0, you start at 1, right? That's starting at your max. For cosine, you start at max and it just keeps on alternating. At pi over 2, it goes to the midline. It goes to the midline. Then it goes to the minimum. Then it goes to the middle line. And then it goes to the maximum. In cosine, in the value context, is 1, 0, negative 1, 0, 1, but that's simply translated as max, mid, min, mid, and then max. So those are your 5 values, and then I'm going to connect the dots, and I'm going to get the graph looking like that. Then I do the same rule here, mid, min, mid, max, and then you get this graph like that. So if I go to my original red line, okay, that I can literally take and then plot it right there. That's your regular cosine of x. It looks like kind of like a stream of river in a way. But if you move it down 1, you would see how it matches exactly the same as before. Okay, so that means that you're doing it correctly, and also you're visibly able to see how this moves down. So my first suggestion to you is to please set up your frame. You want to have a good habit of doing this, because especially when you're trying to do a complicated trigonometric graphing by hand without using any sort of device whatsoever, it's important that you have a frame so you can work amongst the minimum, maximum, and middle line. Let's try one more question here. Graph the following on the same graph. Now notice how I'm giving you 2 cosine of x. So I'm literally telling you to use amplitude and vertical line, a vertical shift, that's different from 1. This is going to be implying for both of them, and I need you to plot both of them. Pause the video, and then try doing this on your own. Let me know when you're done. Okay, so first I'm going to plot 2 cosine of x, and probably you guys should already know that it starts at 2, middle, minimum, middle, maximum. So we're doing cosine once again. So for homework, I'm probably going to give you some sine and cosine, both of those one at a time, so you can get the hang of it. So that's my regular 2 cosine of x. So I have it ready. My next one in the list is now 2 cosine of x minus 1. So I'm taking this graph and I'm literally drawing down by 1. Now I am going to erase this part. So when you guys are doing this question on the homework question, guys, please just do this first. I mean, I really am not going to ask you to draw the original again. You're just going to be asked to graph one equation. So when you're graphing this, what's my first step? Set up your framework. Okay, please set up your frame. My middle line is at -1. My max is at +1 because notice my amplitude is now 2. Then I go down to -3. Those are my framework. So this is my max, this is my mid, and this is my min. Okay, so now I have the framework, and then I'm going to repeat the cycle of max, mid, min. So I start at the maximum for cosine, and at pi/2, right here, I go to mid, then go to min, mid, and then max. So I just plot those 5 points, keep on alternating, and then I am going to connect the dots. Okay, and then now let's verify with my original red cosine. So if my original cosine looked like this, where my midline was here. Okay, good. So my amplitude was 2. So I'm literally taking them moving down 1. So take a look at where the 0, 2 is, moving down to 0, 1. And look at that. The shape is pretty relatively the same, but you get the idea. So this would be how you would graph both of those. Or you can just graph the red line and just move everything down by 1. That's also okay, but if I literally ask you to just graph one of these, then I want you to have the framework. I know that you guys can literally take this and just plot those 5 points down 1, and then you can just get the answer, but set the framework. I'm going to specifically ask you to set up the framework on your homework questions. So something like this, you will see, I'm going to give you a question like this on a homework to do. So you will see one cosine function and you will see one sine function, and that's going to be it for today. All right, thank you and have a good day.